Sorry for such an abrupt ending to that, but we're not at the end of the problem, we're still in the middle. So remember I chose these 2 points. I did change my screen a little bit so I could draw a line. Not like you really desired it, but whatever. I just felt like we needed to. So if I draw a line and say, oh, this line looks like a really good approximation, because even though these few aren't there on the line, I really feel like it looks like the trend is going this way. So this line is going to be the model. I can justify my choosing of those 2 points. Whereas somebody else might go ahead and choose, I don't know, maybe these two and say, oh, well, these 2 points, I'm going to draw a blue line, seem to be not straight apparently. These 2 points seem to better approximate the data in their mind, even though the upper ones are off. So it really is somewhat of a subjective move. And, as you'll be graded when you do this, we can understand and recognize that there's some wiggle room. Anyway, so let's take these 2 points, like I said before, and let's find the equation of the line that fits through those 2 points. So here are those two data entry points that are highlighted. So I've written them as points here, and we can call to mind the formula for finding the slope, because as soon as we get the slope, we've got the slope and at least 1 point. Actually, we've got two. We've got the slope and a point, and we can use point slope form to find the equation of the line. I don't think they asked a specific way to find the equation, so it doesn't matter. Once we're not asked to give it in a specific form, any form is acceptable. And so at this point, I'm going to just apply what I know. I'm going to take the difference of the y terms over the difference of the x terms. And if we do a little bit of calculation, I know I'm getting a little sloppy here, but the slope is going to be 4,655 over 4. Notice the 1 point, I'm just going to do this, just a keeping, like a, accounting kind of thing. Notice how when I subtract the y's, the difference between the y's over the difference between the x's, I'm going to make sure that the x term and y term are on top of each other, that belong to the same ordered pair. Just wanted to point it out. Okay, so I'm going to reduce this rate if I can, but I actually can't. I noticed that this is not even an even number in the numerator, so it is better to leave your slope as an improper fraction. I know you don't want to, but we're still working on this first part, so let's go ahead and keep fighting the good fight. So we've got the slope and we've got a point. We can find the equation using point slope. Remember, which point do you like? It doesn't matter. Both of them will yield ultimately the same equation. And so since I've got my slope to be this unwieldy number here, and I have my point, let's choose this one, 12, 12 comma 19,802, I'm going to use that in the point slope formula. Y minus y sub 1 is equal to m times the quantity of x minus x sub 1. And I'm going to just literally plug and chug that answer in there. So y minus y sub 1, so y minus 19,802 is equal to 4,655 fourths times the quantity of x minus 12. And so that indeed is the equation. So now assume that the rate of growth for personal income remains constant over time and use this equation to predict the average personal income of an individual in the year 2010. Now let's go back to what the year refers to. We remember that the year was in the X column, right? We were dealing with the year that way, but we didn't actually put in the year, right? We put in the year since 1980. And so if we're talking about 2010 and we're starting at 1980, we need to consider how many years have transpired since 1980 if we're talking about 2010. That's the X value that we need to substitute into this equation. So for this situation, X would be, hopefully you guys see it, X is going to be 30, right? Okay, so if X is 30, to calculate the Y value, we're going to plug 30 back into that equation and we're going to figure out what Y is. So plugging in 30 here is going to lead me to having on the right side of the equation this large number, 20,947, 20,947.5. Moving that 19,000 number over, we end up with about 1,749, which is pretty interesting. And then evaluate the prediction. We can go back to our graph and say, yeah, it looks like that's what's going to happen. It seems like everything's in line. What I wanted to actually show you guys is what the textbook did. And I know you can do it on your own, but just wanted to show you that the textbook got a different answer, but both of them are good enough in terms of doing what was asked in reference to the question. So check this out. So we're over here and we're just taking a look, and I don't know why this looks so crazy. Anyway, so they graphed it, they chose 2 points. They happened to choose the first point and point 17, the point related to 17 years after 1980. And you can see that they got a slightly different answer. Their answer was a little bit less, 37,696, whereas mine was 40,000. But meh, I feel like it's not that big a deal. They felt like they supported their answer by saying, well, most of the actual data made sense in reference to the graph because the lines were so close, the points were so close together. So I just wanted you to see that, yes, we can get correct answers based on, that are different based on the information we have. And with that, I'm done. We're done with this section. I look forward to talking to you guys soon about section 1.5.